So that's all for the different metrics and the probes that we are using. Let's go on and move on to more practical aspects. So general considerations, you will see that a lot of the sensors have something that we call KCl creep, or potassium chloride creep, which is basically a small crystal deposit on the probe itself, which is basically due to a consequence of how we store the sensor and the chemical composition of the sensor. So it doesn't have, there's no problem with it. You just can clean the sensor with tap water or distilled water, and we are ready to go. This has been happening forever in all the different sensors, and you will notably see this on pH, electric conductivity, dissolved oxygen, ORP sensors mostly. We will see that a lot of the sensors require preparation. You need to do this before calibrating and before taking measurements. And you will need to maintain the sensors periodically as well, because it is, if this is not done properly, then the measurements won't be valid. And we will see, of course, for each of the sensors, what we have to do. The very first of them is this potassium chloride creep. That is, as I was saying, not really important at all. So the famous cables. You will see that all the probes that can be extended, basically beyond 1 meter cable length, you can extend that cable to either 5 meters, 10 meters, 30 meters. These cables are very particular and need to be handled with care and cannot be replaced unless they are the same type of cable, because they have a very particular resistive range. And you will see that we are leaving connectors, metal connectors exposed, and these can't be submerged, and it's important that we don't do that before protecting it. So to protect it, we will provide, or you can as well, access to these hand moldable plastics. Normally, a brand from the States is called coax steel. That is basically plastic that you can just wrap around the connector, and that will basically weatherproof it or waterproof it, and then you can simply just submerge this connector and you're good to go. Important is that, of course, these connectors are not waterproof, but also that in the case of the temperature probe, since it's a resistive sensor, we need to recalibrate. So if you change the cable, you need to recalibrate it, because we are affecting directly the measurements by extending the cable by adding more resistance with a new cable or removing it. In terms, probably the most difficult one that I mentioned earlier, let's go with it. So it's the dissolved oxygen probe. Whenever you open it for the first time, you will see that it has a protective cap. So basically, it has a cover, a rubber cover that protects the tip of the sensor. But you will also see that it has a small Teflon membrane that is not to be removed when you open that protective cap. So whenever you open it for the first time, be very careful and do not open or do not pull apart this part as shown in the picture, but only remove the protective cap. That is very obvious, but sometimes if you pull hard or too fast, it will come, the membrane cap will come along with the protection. Also, this sensor, even if they are new, well, you need to perform this preparation. So the sensor basically has what we call an electrolyte solution inside the sensor itself, which allows for a chemical reaction to happen. So in this sequence of actions, you will see how to replace this electrolyte solution. So basically, you have to unscrew the cup, open it, and fill up this cup with electrolyte solutions, and then close it again, and then rinse the probe. This normally happens every 6 months. So this electrolyte solution, as the reaction happens, will deplete, and you have to refill this electrolyte solution every 6 months, roughly, sometimes even sooner. So we encourage you to plan maintenance sessions for the sensor, and the first time you receive it, you should refill it in case it's empty. Also, you will see that the sensor regenerates a solid residue. So as the chemical reaction happens, this is there will be zinc oxide accumulating on the sensor probe, and you will need to clean it as soon as you receive the sensor. So as soon as you open the and screw this cap, you can dump the existing electrolyte solution, and before replacing it, you should file this part, the part of the sensor that has probably accumulation of zinc oxide. Be careful to not affect the tip of the sensor, so only touch the, let's say, clearer metal part, and you can simply file it with either sandpaper or a more sturdy file. You can clean it afterwards, and then you can proceed with refilling the electrolyte solution. These also will accumulate over time, and you can clean it every roughly 5 or 6 months. But we encourage you to see, because we haven't deployed ourselves the sensor for so long, and we would suggest that you evaluate these based on where you deploy it, because a higher activity will also lead to higher maintenance requirements. And finally, on this cap, there's a Teflon membrane. This Teflon membrane is allowing for oxygen to pass through, but it doesn't allow for water. And there's no exchange of liquid in that membrane that is basically in this cup here. Whenever you open the sensor, make sure that that is not damaged and that is not broken. And also make sure that you clean it with a very soft brush or a very soft like piece of paper, or this is very soft material, so that you don't damage the probe. If it's damaged, there's a replacement wand already included. And if you go beyond that replacement, then you have to order a new one, or ask us for provide a new one. And Atlas Scientific will provide for one of those. When cleaning, do not use strong brushes inside or in the membrane area, but on the side it's okay, but not inside or underneath. And you will see as soon as you have a look at the sensor. In terms of the pH and ORP probes, you see that, again, they have a very delicate sensor component on the tip, which is made out of glass. And you can imagine that this is quite small and delicate. And they are stored in a storage solution in a small soaker bottle. And this is the sequence of opening that soaker bottle. Whenever you don't use the sensor and it's not submerged in water, you should put the soaker bottle back on. So please take care of that, because otherwise the sensor can be damaged and it has to be, let's say, reconditioned otherwise.